Okay, so we're about to jump into a fairly hefty but interesting lecture called Designing for Maintainability. It's lecture 5.4. I'll give you the why for the why. Take a step back here. So, something that I've spent a lot of time doing over the last several years, and something I probably enjoyed the most throughout most of my education in computing, was helping students understand the importance of software design. You know, how to write good software, because you can actually write software that's correct and bug free, but it can be crappy software. You know, there's a certain like elegance to it, and it's not really taught in any crazy depth in the right way, probably anywhere in the degree. Maybe not as much as it could, at least. Probably the better thing to say. And it's hard to teach as well. But it's all what falls into the design area of software. You know, this is like, and what am I talking about here? Because I'm getting on a bit of a babble, but you know, have you ever written some code and your friend has written the same code? Maybe they've done the same lab and you've gone and looked at their lab and you've just gone, gosh, that's clean. That's nice. That makes sense. That was easy. You didn't overcomplicate it. You know? Or on the other side, have you ever written code and like after it, you've gone back to it a week later, you've just gone, this thing is a nightmare to work with. Feels like, it feels like the equivalent, like, and you might make, what it's like, you make something in the kitchen, and you make a big mess, and you're just like, oh, this is a nightmare. Sure, I made the cake, but like, this isn't good. I can't sustain a kitchen life like this. There's all these stupid analogies I could come up with, but it's all really about, doesn't matter what the outcome is. Sometimes we like to do things well and do things properly. I would love to teach this more in this course, but to be perfectly honest, one of the issues is that when you teach people about software design who've maybe only been programming for 12 to 16 weeks, it's hard for it to kind of hit them as clearly as people who've programmed a bit more. So it's a little bit hard to really emphasize some of the principles that we could apply, right? And that's okay. That doesn't mean we can't talk about it, but what it means is that we have this kind of one lecture where we talk a lot about software maintainability in the course, and I'd love to talk about it, and I could talk about it for hours and hours and hours, but we have lots else to talk about. But this one is really important. I think this is a very important and exciting lecture, and I hope, if nothing else, if you do pay attention to the details of what we're talking about, I hope that as well you will be able to walk away being motivated to apply this desire to learn about software design in everything you do, because, and this gets back to the why of the why, it is what separates you from other people. I say this a lot. I say this every term I teach 1531. I've said it since the start. Your ability to write code is not that exciting, frankly. Many people can write code, and many of them will work for less money than you. So okay, you can build a website. Good on you. Lots of people can. More and more people can every year too. You want to be known not for the person who can make things with code, but for the person who A, can make things with code that are correct, different lectures, and to make things with code that are built elegantly, that are built well. And if you can do both of those things, you will be a force of nature in the development space. If you can't do either of those things, you're just going to be, it's going to be a question of why would you, the example I always give is, why would you not just hire someone overseas who maybe had a shorter education or a cheaper education or just something else, because anyone can write spaghetti code if they just, put their mind to it. So in this lecture, how we're going to approach good software design, writing good software, is to stick to this more fundamental idea that maintainable software, that software that works for years, right? Think about that, just anything in life that you're just like, wow, it's lasted forever, and I haven't had to throw it in the bin and buy a new one. So maintainable software is resistant to breaking. It's resistant to breaking and needing to be thrown out, or breaking and losing a bunch of money. That was poorly. I ended the sentence in the middle there. Our software is resistant to that. It becomes maintainable when inevitable changes occur over time. That's what our goal is. You know, if like as time passes and as new people work on software and as things change all over the place, our software still is resistant to breaking. It's still resistant to being thrown in the bin. Then we have what we call maintainable software, and that's a good thing. That's why this lecture is called Designing for Maintainability. Now, what are we going to talk about? We're going to talk about why we care about maintainability a little bit. We're going to talk about how we maintain software, and then just more examples of increasing that maintainability. So, bit of a recap. What is software engineering? Back to week 1. Software engineering is where we focus on building the right software for the right people and making sure that it's maintainable over time as it grows and the people who work on it change. Now that's quite interesting. Building the right software. Correctness. Building it for the right people. That we talk a little bit about in week 8. And making sure it's maintainable over time as it grows and as the people who work on it change. That's what today's about, right? That particular section there. So we'll discuss that today. Why do we care about maintainability? We've chatted about a few of these things in the preamble, but software in the real world changes over time. Pretty much no software that's actually used by people is just built and then exists. Very few cases of that are true, right? There would be some. And if they are, they're usually low-level systems, and they tend to kind of probably break into like the mechanical or an electrical sphere, right? Like, I'm sure some of the least changing software over time is like the software that probably runs, like nuclear power plants and just things like that. Things that like the software had to be written. It had to be really simple, and no one wants to touch it because it works. You know, they wrote really simple, small software. They got it right, and then they like leave it alone because it just kind of works. But reality is 99.9% of the software you all interact with, or like 99.9% of you will interact with software that just changes over time. And if your software is not maintainable, if it's written poorly, as it's forced to change, it will be a pain to change. And what do we mean by pain to change? I might kind of have this written elsewhere, but basically means that it will become more buggy, or it will cost more money, right? So if software is hard to change, when you change it, it breaks. And you know what? If someone says to you, well, change it, but don't break it, you know what you have to do? You have to spend more time on it to test it more or to really triple check. And that costs money, right? So, this topic is actually more critical than ever in some ways because of how rapidly iterative modern customer software is, you know? Like, we write, like, most software you use is just, like, pushed out all the time now. You know, it's not like years ago where you'd push something out a year or two. You know, you push out a video game and it just stays like that forever. Software's pushed out really, really frequently. But then there's that question, why does it change over time? I've kept saying that like maintainable software resists the tendency to break as it changes over time. Well, different people work on it. Different people bring different programming styles. They'll see things, they'll miss things. You know, maybe they'll be like, oh, we need to account for that. We weren't accounting for that before. The requirements change over time, right? Like think about a product like YouTube. YouTube has shorts now, right? Well, it has shorts because, you know, was like TikTok, is that the thing? TikTok kind of heard it and scared it. So now they've got shorts. So their requirements of what they wanted to build changed over time. You need to increase performance sometimes. Maybe as you get more and more users using something that you do, you have to kind of clean up your code. You have to make it run faster because otherwise everything explodes. So you have to go and change your software again. And then also fixing bugs. Every time you fix a bug, you tend to have to change your software anyway. So code always grows. It never shrinks, and you will never get on top of it. And you just need to be ready to adapt. It's a little bit... I'm trying to think of what a good... You all probably get this because you study, right? You know what it's like. Some of you would have seen this, and this is not everyone, but most of you. In high school, you might have taken crappy notes in high school or something, right? Has anyone ever got a Google Doc or just like a pen and paper notes, and you take these really crappy notes and you think, I'll wait till I have some spare time and then I'll go back through them and I'll clean it all up. That never happened, did it, for most of you, right? Some of you it would have, but for many of you it just wouldn't have, because you just don't have time for that. And again, in the real world, when you're working with an organization or an institution that's trying to write software, there's always so much pressure to move forward. You don't really ever often get a chance where someone says, you know what, just take a few months and just really go and like make it all nice just for us. You don't really feel that, because in the world of mostly monetarily motivated software, there's always that question of what value is this providing the organization? And this isn't just big business, right? Like it's everything. Every organization is trying not to waste money, right? Not-for-profits tried not to waste money just like everyone else. So don't think it's if you're one of those people who are like, I don't want to work for a big greedy company. It's like, well, no, everyone doesn't have time at the end of the day, unless you're working for free, in which case, why would you want to waste your life working for free trying to maintain software that you didn't maintain well? So maintainability is also more important than performance. There's a great, I think it's from Rob Pike, has some great phrases here, which I've gotten, which is like, if code isn't maintainable, then performance issues will appear more often. And what that means is that if you write bad or inelegant code, then as you try and fix it or fix bugs, what will happen is that, sorry, my brain just died. What will happen is as you fix bugs, performance issues will appear, because you have to kind of, tweak levers and pull things and add things, and that'll slow it down over time. And the good thing is, if the code's easy to maintain, it will be easy to speed up, because things tend to be more modular and well separated. So if code's easy to maintain, it's easy to change, and performance improvements tend to be changes to the code. So if it's easy to change, it's easy to improve the performance. Now, that was a lot of maintainability. We get why it matters, but how do we make software more maintainable? That's the next question. So a few key ways to make software more maintainable. There's testing. Testing makes our software more maintainable because what we can do is we can make changes to the code without worrying about regressions and correctness. And you probably have felt this already. You've gone and written a whole bunch of jest tests before, no doubt. And then what's happened is that you have it's all passing, and then you come along and you make a small change to the implementation, and then you know what? It keeps passing, and you think, damn, that's awesome. I feel comforted inside, right? Like, who's felt that? I'm sure you felt that. You're like, man, my tests make me feel safe. That's the purpose. So testing is a great way to improve software maintainability, because it can give you more confidence to change the code when it inevitably demands to be changed. You can also you can also approach software with a high quality of system design. And that essentially means that, think about this as the not code element, but like the sitting down with, like a Miro or something, a mind map, a brainstorm of like, what are channels, what are users, how will all of these components interact together? Let's get a good conceptual, diagrammatic, visual understanding of these things together before we go and actually write code. We talk about this a little bit in particular next week with conceptual modeling, and we do it a little bit with software complexity, but to be honest, mostly it's on conceptual modeling next week. And then the third one, which is a lot of what we're talking about today, which is code design. And that's thinking at a high level about how easy it is to make code actually like work for us. So it's all about good code. Clean code is one of these parts. Clean code isn't everything that makes software maintainable, but it's a massive part of it. That's what we're talking about today, yes. So code design is really just what happens between when you write your tests and when you actually write your code. And again, if you haven't labeled it this, you've thought about this before. Every time you write tests and you have an implementation to do, and you're like, I can do this, but I haven't actually written the code yet, you're thinking about the right way to do it. And sometimes it's not just like, sometimes you might have an idea of how to do it, but you think that's an ugly way to do it, that's a silly way to do it, that might cause me problems later, so I'm not going to do it. That's all code design. It's that how to do it and how to do it elegantly. And the thing to remember, and this is really important, our tendency is to not write well-designed code because we are in a rush or there's pressure on us. A bunch of you would have felt that through the iterations already. And good code design just takes a little bit more time and energy, and it's okay to sit down and think, you know what, I'm actually going to pause for 5 minutes here and think very deeply about what I'm trying to do. Now, the way that after many iterations of this lecture's changed quite extensively. How I like to approach it now, instead of kind of teaching you all these principles, like the A, B, C and the D, E, F principles and all this kind of stuff, I actually think that the healthiest way to think about good software design to make code more maintainable is to ask yourself questions. And the questions are great because when you teach people principles, it's a very personal and very isolating thing. It's for you to sit down and apply the principle. But I love questions because it opens up your capacity to work with other people much easier. Because if you think about these, I have 6 design questions to ask, there are 7. If you think about these 7 questions, I think one of them I grouped together, 6 or 7 questions. These are great because it's very easy to go to your team member or someone you work with in the future and ask them a question such as, is this as simple as it possibly could be? And have a conversation about that. How could we make it simpler? So questions are really good. So we're going to focus on questions. So question 1 here, is there one source of truth for this? This is one of the oldest kind of tropes of good software design, not tropes, like tenets of good software design that you've probably come across back from 1511, which is that when you write code, if you repeat yourself, i.e. if you define the same thing in multiple places, a change in that value or capability requires changes in all locations. You might know about this through magic numbers, or they might be referred to as magic numbers, and it's a fairly easy idea, right? Let's say think about a C style thing. You got like an array of 5 items, and then you go and create a loop, I is less than 5, something like this. Like this back from C, you'd be like define array size is 5, and then you just go and grab that and you replace that. That's an answer to the question, is there one source of truth for this? Because the answer to that question was no. There's not one source of truth. There was multiple sources of truth. So we want to kind of undo that, right? So the question prompts an action. And to avoid this problem, we follow a don't repeat yourself method, which focuses on just not repeating yourself as much as humanly possible, right? And another way of framing it is that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Now that's a big, kind of scary, abstract sentence, but it's very true and it can be applied to most things. Every piece of knowledge within a system, think of system like software, should have one, we might more colloquially between us call it a definition, but representation is saying, it should just be represented, defined somewhere in particular. Now, we can have a look at some code like this. For instance, if I open up 5.4 dry, this is a fun little piece of code. It's a bad, ugly piece of code that I wrote. And what we're going to do just as a quick group is like apply that principle of not repeating ourselves. So open question to everyone here is just like, what would you do to make this code a little less repeaty of yourself? I'll give you a moment, but shoot some ideas. Tell me what you do. If you saw this, what would you actually do to change it? Use constants for magic numbers. Yeah, so that's one thing we could do. What we probably noticed, let's actually first talk about what this program does. npm run ts node source 5.4 dry dirty easy. Okay, well it didn't do anything because I should probably read the code first. We import argv from process. You can do that a couple of ways, but let's say we're getting the argv, that's the command line arguments when we call the program. We check if the argv length is not 3. Now 3 means it expects 1 extra argument because you've got ts node, the file name, and then the third one should be that extra argument. So if it doesn't have 3, it exits. If it does have 3, it goes and pulls that particular argv and turns it into a number, because remember every argv is basically a string. And then if the number's 2, it does some stuff, or if the number's 3, it does some stuff. Otherwise, it also exits. So this means that if I enter nothing, it doesn't run anything. If I enter 5, it'll do nothing because 5 is not 2 or 3. But if I enter 2 or 3, then what it does is it goes and gets all the numbers between 10 and 19, and it raises the number 2 to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and it prints out the result. It basically just like uses it's just like 10 to the power 2, sorry, 10 squared. Is that right? Yeah. And this one's like 10 cubed. I'm just using some Python syntax, but so you see in this case it's like 10 squared is 100, and it does this, and it does it for 3 too. So if you enter 3, it goes and does it for 3. Okay, now use constants for magic numbers. Okay, that's fair. Sometimes it's good in JavaScript to use uppercase for constants. So let's say like loop low end is 10, and we'll say like loop high end is 20 or something like that. And then we can go and replace these two things. Instead of 10, we say like loop low, and instead of 20, we say like loop high. Kaiki says, compress these if statements into a function and then set the argument as num. Great. So Kaiki's like, okay, well, both of these like kind of, he says if statements, but let's do for statements. These two things are very similar, so we can probably abstract them into a function. And I'll say with this function, it's like, print, what would you call it? Print powers or something like this. And I'll use the new function syntax, right? Just for a bit of fun. And I'll go and copy this in, and we'll pull out things, we'll abstract out things that are, not common. And the main two things you can see that aren't common are this 2 here, because the 2 appears twice. So I'll call this like, the power, or power, like that. And then we'll just pass power into the function, and because it's TypeScript, we'll say it's a number. Okay, this is handy, because now here I can just say print powers are 2, and then here I can just say print powers are 3. And already what we've done, right, is we have reduced the definition of something, particularly this function, down to one spot. So now things, are much closer to only having one source of truth. Now you could argue that you don't actually need to make this constants anymore. This is a bit of a murky area. Some people, like in some code, it's really about, will this number change? Is it easy to have it represented up the top? Sometimes, even though the 10 and the 20 are actually only represented once, sometimes people still prefer to pull them out so that you can actually kind of like see them in one spot. I think that one's kind of on the border. You'll also see down here we could simplify this code more. And we could repeat ourselves less in terms of calling functions by just saying, well, you know what, if num equals 2 or num equals 3, then just call print powers on num, right? So our code got much simpler very quickly there already. Now, one of my favorite things about this example, and this is normally when we have more people turn up, is that someone usually says we should like extract process.exit into a function. We'll call it like exit. And all this function is going to do is just do process.exit1, and then we just exit like this, This is interesting, because when you make that change, you are actually making that change in the spirit of not repeating yourself, of trying to answer that question that we had in the slides, which was, is there one source of truth for this? And you think now there is, because previously we had 2. There were previously 2 places where we defined what it was like to exit the program. And this is and this is why I like questions as well, because there's not a lot of answers when it comes to software design. There's not a lot of unambiguous correct answers in software design, but there's a lot of interesting questions. So the plus side of what we've just done is we now know that when we call our exit function, that exit function will have one source of truth over how the program exits. But there is a downside of it, which I'll kind of get to, see if I remember it back in point 7. So for now, let's say that looks good, and we'll move on and come back. But this code's like been pretty well reduced in terms of, the one source of truth part. Let's look at the second question now. The second question is this as simple as possible? Maintainable software tends to be simple. The better a programmer gets, generally the less complex and less difficult their code is to understand. So fairly typical trope you will see with, like first year computing students is that as they first get into computing, and they get over the initial confidence, it's kind of it's a bit of a thrill, it's a bit of a buzz to write complex software. Makes you feel smart, right? Because you've written something that was really hard to write, and that is like kind of, that's the validation in and of itself. But in reality, the simplest software is usually the most maintainable. So when I look at, say like the people I've employed over the last couple of years, generally speaking, it's quite straightforward. The younger they are, the more complex the software is, unnecessarily, and therefore the more difficult it is to maintain, and the more often it breaks. So it comes from this idea that the more code we write, the more code there is to maintain. It's actually one of the simplest things to understand. So when someone says, is this as simple as possible? They're not questioning your intelligence. I wouldn't think of it like that. I mean, unless they're rude. I'd more think of it and say, well, hey friend, every line of code you write gets us one step closer to a difficult to maintain code base. So, did we have to write every line of code? Were there some places where we could have, replaced 5 lines of code with 1 line of code? And there's this quote I love, which is that every line of code you don't write is bug free. And it's a cool idea, right? Like if you write 10 lines of code instead of the 20 you were originally going to write, and lines of code is not always the best metric, but let's just use it. If you write 10 lines of code and not 20, those 10, let's say, if you write 10 lines of code and not 15, those 5 lines of code you didn't write are guaranteed to not have issues because they don't exist. So you should always view kind of like writing code as a bit of a burden in a way, right? It's like risk. There's not a lot of downside to not writing something that's unnecessary, but there is some downside to writing something that is necessary. Sometimes you'll hear this principle referred to as like keep it simple, stupid. This isn't just in software, this is just in life in general. And it is the idea that things work best when they're kept simple. And it's the idea that complexity and errors are correlated, right? Sometimes they're causal in the sense that a complexity will lead to an error, but that's case by case. But it's more that the broader idea is saying, you know what, we think there's a correlation. Software that gets more complex tends to have more errors. And again, just to reiterate this principle, it is the idea that kind of clear, simple code is much better than clever code, and no person really likes clever code if it could be no sane person who's got some experience likes clever code if it could be simpler. And one of the simple code is pretty easy to think about in terms of we could have made this previous example much more complex if we wanted to. We could have come along and what's an example? We could have made this string very hard to read if we wanted to, like say, const left-hand side equals I plus power, const right-hand side equals result, something like this. You know what I mean? Like you can always make software more complex just by writing more lines of code. And if you never and one way to think about it is that simple gets really complicated when you think about it from a very non-human standpoint. When you think about it from the perspective of, oh, is this simple algorithm or something? But I would encourage you to go just a much more straightforward approach, which is this easy for someone to understand? Because if you make it harder for someone to understand, there's a good chance it's inherently more complex. So that simplicity matters a lot. And probably one of the most basic ways to keep things simple, which comes back to the idea of every line of code we don't write is bug-free, is to use libraries that exist. And it's, again, a common thing you'll hear from experienced software engineers. It'll always be that question, has someone done this before? And it's something, again, you will get better at. Generally, the typical student will typically get better at this as they mature. When they see a problem, they won't jump to, oh, how can I solve this? They'll jump to, who's done this before, And there's this quote, it might even be, I swear to God, it's from like Toto from F1. But I don't remember it exactly, but it's like, everything you do in life and everything you will do, there's a nearly guaranteed chance that someone else has become an expert on it in a way you never will, right? So I think I might have butchered that, but The idea being that, when you get asked to solve this problem, I want you to write a function that generates a random string with up to 50 characters that consist of lowercase and uppercase characters. It's like, well, that's an interesting problem. You start thinking about ASCII and you think about loops, and it's like, no. There's such a high chance that someone else has already solved this for you who was probably smarter than you, and therefore your approach can be simple by just leveraging their intelligence. And that makes your code less buggy because, someone has probably spent a lot of time solving this problem and you need to dedicate an hour of your day to solving this problem and you're not going to get it right. It's the exact reason that we use these NPM libraries and everything else. So let's say we do look at, I'll just butcher this file here. Let's say we do want to generate a random number. Maybe I'll write a function called random or random string. And let's just say for now it returns A, and we'll just call rand string for now. Or console log it. Just test that it works. Should just print A. Yep. So the question was generate a random string with up to 50 characters. So, I might do what we normally do. Node.js random string. Generate random strings using regular expressions in Node.js, and I kind of look down here and play around with it for a little while. Okay, there's some interesting code here. Do I have to install anything? Yeah, it looks like I have to npm install this random expression, so we'll try that one. Cool. And then we've got a code sample down here where it looks like it generates some random strings. Okay, so I'll go and I probably have to import that, no doubt. Someone else, where's the import? Yeah, so import random expression from rand expression. I've never used this library before, not that I remember at least. And then we say here const random expression is equal to new random expression. And then this is some regex. Regex is like a particular, like a small, I don't know if I call it a programming language, but it's certainly some kind of like descriptor language that you can use to generally filter text. In this case though, if you were to Google around a bit more, you would probably find a variant of this where it would show you how to do it. I know how to do it in this case, but again, I've seen other examples of this on the internet, which just a bit of digging can find, which is to say that if you want uppercase and lowercase characters, you're looking for all the characters that are A to Z lowercase or A to Z uppercase. And what this particular example is doing is it is simply generating one that's between 3 and 9 characters. So when I call this, I'm going to get a random lowercase uppercase string between 3 and 9 characters. So now if it's like, oh, I want it to be 50 characters, well, I can just say, well, generate me one between 50 and 50 characters, and I haven't printed this out properly because I need to, looks like I need to do something .gen, I guess. Is that what it is? Okay, sure. Might change that back to 3 and 9. .gen. Yep. See if this... so clearly what's happened here is this is some kind of object. But... So that's what I was doing here was printing out some object that gave me a bunch of info. But I actually had to take that object and generate a number. So in this case, I get some random, 3 to 9 character length string. And I probably get a... Yeah, this one is slightly smaller. But if I say, 50-50 here... Now I'm going to get a 50 character string, and we've kind of solved the problem already. Doesn't even need to be that big a function. I'm sure you could just put gen at the end here. I'm sure you don't need all of this. My editor's being weird. I can't see the cursor moving. Yeah, so you could probably just do that, where you just return that. There's your function. Or again, you could really go hardcore JavaScript syntax here, like we've talked about in previous weeks, and just do that. Like, there's your function. That was simple, wasn't it? Very straightforward, very easy to understand. You can look up the library. So that's very powerful stuff. There was a few more questions here that we're going to go through in different cases. Write a function that prints what day of the week it is today. Again, the same thing. You don't need to get caught up in, time zones and all this other complicated stuff. You can actually just kind of leverage libraries before, for instance, again, what day of the week it is today, Node.js day of week. how to get the day of the week. You know, like Google's a very powerful thing here, and it's very easy to be like, oh, you know, blah blah blah. I shouldn't have to use Google. That's like kind of a cheap way to learn. And it's like, well, look, it's how it works. Day.js returns the current week. Day of current week. What's this? Day.js. That's an interesting library. Do I have to install it? Installation. Is it going to give me an npm install, hopefully? Node.js. Oh, well, there you go. There's literally a library. Every time I don't prep some of these examples very much because I try and date functions. We've already seen date functions, so I could just do that again, but to show you something fresh, let's try this out. I've never used this library, I mean that. Day.js sounds interesting. Let's try, and what was the example we saw here? Day.js.day. Okay, let's try that. Oops. Day.js.day. And then it's all we have to do is like import day.js from day.js. That doesn't look good. Bit worried about that. Sometimes actually sometimes you can actually run into issues, and we might run into one here. Okay, maybe I need to look at some examples. Installation. I don't know. Let's try printing some stuff out. Oh, sorry, I'm missing the brackets. Very silly. Very silly. Okay. So 3. Well, okay. That wasn't super exciting. I don't want 3, I want Wednesday. You know? But I'm sure if I Google it some more, I go to date functions, you know, the date functions library, day of week. Thank you. There'll probably be something around, you know what I mean? There's like always something. Sometimes just a case of looking through the docs, you know. So in this one, it's like day of week. What do we get? Get day of the week. You know? Okay, I get some number answers. That's interesting. All these libraries will give you number answers, like 0, 1, 2, 3, 4, 5, 6. But you know, let's say you want something that's, you know, like the point is that if you okay, here's my point in this example. You're like, cool, day 3. Now what's your temptation? I'm gonna go and create some kind of like day map where I create an object where I like, you know, I map 0 to Monday and I map 1 to Tuesday or something like this. Except I think this is probably Sunday. You know, and I do this for all the different days of the week, right? 2, 3, 4, 5, 6, like this. Saturday, Friday, Thursday, Wednesday, Tuesday. And then here, and I get my day of the week, and then I simply, you know, get my day map and access that particular index, and now it should print out Wednesday, right? Okay. I've solved the problem. But I don't think what I just did is good, is my point. I would be shocked. I don't know. I really don't. I'm not going to waste your time looking at it because we don't ask you to really do it. But I don't think. I would be shocked if I was the first person to have to solve this problem, and I mean, that's obviously not the case. But I'd be shocked if someone else didn't wrap this into a library, and to find it, all I needed to do was actually just go and like look up some more documentation on the internet. And I could avoid that because this is the problem. It's like, okay, every time you write code, you know, there's a chance someone else will misunderstand it. There's a chance that the indexes might be wrong. There's a chance that there's a typo. You know, another library out there might be able to do days in different languages for you, right? Because dates are universal, days of the weeks are universal, but the language is different. So a library might be able to convert, and this is, think back to the original point of this lecture. It's like, we want to write software that resists the tendency to break when it's inevitably forced to change. So if you write some software and then It's like, well, we need to do it in French now. Well, you're going to start doing something silly here and start going, well, we got the English version, and there's the English version. And then we got the French, you know what I mean? And then suddenly you've got all this stuff to maintain. Whereas if you just use like a library or something simpler, then it's a bit easier. So these examples are all predicated on top of using a library. There are many other ways to keep software simple. You will just naturally figure this out, though, over the next few years as you program more. I don't need to spoon feed you 10 random examples. The point here is that you'd be amazed how much you can do 90% of your software simplicity just by saying someone else has solved this before. That'll help you a lot. Question 3. Is this... I think there's only 6 questions because I collapsed. No, I didn't. There is 7 questions. No, I combined 4 and 5. Is the software over-designed or under-designed? You've probably heard the phrase over-engineered before, right? Like, oh, wow, we really over-engineered that party or over-engineered that problem or something. It's a fairly straightforward idea. If you over-design something, if you think too deeply about how to make it beautiful, you'll spend a lot of time creating very kind of complex abstractions to maintain very trivial changes in code. If you under-design it, then you're going to have to be constantly restructuring things. This is actually one of the hardest things to get right, I think. And an example for you, I'll give you a couple of examples. One of them, at work, we had to design a system a few years ago now, probably like 3 or 4 years ago, where people made deposits and transactions on the system. And I'll just change the color a bit. And what happened was that for those deposits or transactions, we'd have a little database. And that database would say something like, well, deposit $5 from Hayden on, 12th October. Then there'd be another line, deposit $10 from Hayden on 12th of October. And then another line that was like, withdraw $2 from to Hayden on 13th of October, right? And we'd have something like this. And there's an interesting question to ask, which is, well, what's at this point in time here? Imagine this is all the past. How much money does Hayden have? Well, he has $13, right? And you know that because you just went and tallied that up. You said, well, I got 5, I got 10, and then I lost 2. So he's got 13. He's 13 that he's deposited in, right? Money. But to calculate that, we actually had to go through and kind of tally them up. And what this meant was that every time a customer would log in, every time they'd look at their balance, we'd have to kind of quickly in the database sum up all these numbers, which it's a pretty quick operation. But at scale, it can be kind of difficult. It's slow. Because you got, thousands of customers, thousands of times a minute, looking at different kinds of things. So maybe that takes a while. So we said, well, why don't we just keep a running total? So it's like, what we'll do is here, we'll just say 13. And then, when they come along here and they go and say deposit $8, we'll just kind of update the running total to be 21. So you're kind of caching the running total. So every time someone's like, what's my balance? You're like 21, 21, 21, 21. You don't have to go and count the history. Now, this is a really interesting question because, again, most things in software design are questions. Is this approach over-designed or is that over-design? If I do this little caching-y thing here, where we kind of keep a running total, am I over-designing my software and making it too complex? And if I don't do it, am I under-designing it and going to regret it later? Because, what did we say before? We said that the problem is if you over-design software, you've got all these very complex abstractions and things going on, which makes it really prone to bugs and really hard to maintain, which is what we're trying to do. But if you under-design things, you have to constantly keep changing your code all the time as it grows or changes, much more than you'd expect, which can introduce bugs anyway. So if you over-engineer, your code becomes too hard to maintain because you've just got all this crap to maintain. If you under-engineer it, you're constantly hacking at it, and it becomes difficult to maintain because things you hack at a lot aren't going to turn out very good. There is no good answer for this other than experience. That's why people who've been designing software for a long time get paid a lot of money. It's because they look at stuff like this and they look at the surroundings and they go, there's the right answer for you, probably. And this is kind of something that I deal with on a daily basis. you see problems like this, and you think, well, if we don't put more time into it now, is it going to hurt us later? Sometimes no. Sometimes we've gone and built very complex systems. We built a very complex system around giving people credits, like, think about like Qantas points kind of thing. It could do anything. It could deal with different expiry dates and starting dates and different use cases and all this stuff. But so far it hasn't been used. So now we've got a very complex system that just isn't necessary. Like if it was 5 times less complex, it would still do the job. So you get the same output for more complexity. But then other times you might think, oh, we don't want to overcomplicate that. So you keep it really simple, and then you get about a month into using it and you think, geez, this isn't enough. This isn't good enough. We kind of had this problem where we offered 2 different capabilities on the platform. One of them was to invest money into kind of box 1. And the other one was to invest it into box 2. And we said, let's keep these things really simple. And box 1 had this like a couple of different ways of depositing money in, so you had like method 1, method 2, and method 3. And method 1 was like, like a direct debit. And method 2 was, it like, read your bank account and it like tallied up your transactions and something like that. And what happened was when we launched kind of product 2 over here, we just copied the methods because we said, well, let's not figure out how to get them working together. Let's just get them working, right? Let's not over-engineer it. So we kept them really separate. But what we noticed was very quickly, people were getting really confused because they were saying, I don't want to have like these 2 separate things over here. They were like, I just want to be able to give you $100 a week and to kind of have it, have some of it come up here and some of it come up here. I want to use both at the same time. And then suddenly that kind of under design of the system really bit. And there was a lot of work that had to get done to kind of restructure these things so that you could kind of have, a common set of ways of getting money in and sending it out to multiple places. So that's a very hard question to answer, this one. Is your approach over designing or under designing it? And most of the time you won't know until you actually see how it pans out, because whether something's over-designed or under-designed depends not just on your own knowledge or experience, but it depends on, how is the thing you're building actually end up going to be used. There's external factors you sometimes can't predict, but you can get better at it regardless. Yeah. Okay, some other questions. Are related modules kept too close together, and are unrelated modules kept too far apart? So there are 2 important ideas here, which are coupling and cohesion. And we're going to talk about, I don't think I talk about cohesion much in this course, but there's a great term called coupling of software. And it's the idea that if you were to look at software, you could say coupling, the degree to which the software is coupled, is how interdependent different software components are. And think about this in terms of iteration 1. You kind of had a bunch of auth functions, and then you had a bunch of channels functions, something like that. Iteration 1, how coupled they are depends on how kind of grossly connected they are. Like, how could you delete your channels functions and all of your auth stuff still work? If the answer is yes, then they're not very coupled, are they? They're very separate. But if you deleted one and the other one broke, then yeah, they're super coupled because their interdependence is huge. And what these 2 questions 4 and 5 really come back to is a fairly straightforward idea, which says that if you have software things that are related, you want them to feel close together. So like auth register and auth login are so similar, right? So you probably want them to be in the same file. You want them to share the same space. Whereas things like auth and channels are very different, so you want them to be quite separate. So related software components should be tightly coupled, and unrelated software components should be loosely coupled. And the purpose of this is fairly simple. If related software components aren't together, generally very related software components, when you make a change, it kind of affects lots of things if they're related, So if you're going to update how the token is generated, it's going to kind of affect auth register and auth login. So you want them to be close together so it's easy to maintain them in one go. But things that aren't similar, you want to keep them separate because it means you can kind of go and change channels over here without worrying about the impact it has on auth. If you have too much coupling, if things that are not related, it's generally what can lead to spaghetti code, which is just like messes of code. And this is a very abstract one here, right? I'm speaking very abstractly, but it's all really... Ow, hit my finger. It's all really just saying... It's not just like code, it can be files, you know? Like, which files does this function go in? You know? Where do I put these functions in the file with respect to each other? You know, it's not just placement, but it's also like, should I have a function that generates a random number? Can I use this for all these different purposes, or should I separate this out? Is this function for something over here, but I need a slightly different version over here? It's all just really looking at code and saying, is this actually should this actually be this close, or should it not be this close? Question 6 is an interesting one. Am I speculating about how necessary this is? When we write a lot of software, and you might have seen this with your project, sometimes what you'll end up doing is writing code you never use. Have you ever written code that never got used? You might have written a function that you thought you needed but never ended up calling it. You know? This is pretty common, particularly if you're like a very thorough thinker. You know? If you're like the type of person who really likes to plan everything out, you'll tend to get a problem like the assignment, and you'll say, you know what, I'm going to go and write a function that adds a user to the data store, and then I'm going to go write a function that generates a token, and you'll go write all these before you've actually kind of written the functions themselves. You've written like all the helper functions before you've written the functions. This isn't always a bad thing. There are certainly scenarios in software where you really need to think from the bottom up like that, but in general, I'd probably say that a top-down approach to building software will yield you less unnecessary code, because what it does is, if you start writing code from, say, you know, from the functions like auth login and auth register, and the channels as well, you don't have to speculate about what you need, because you'll just kind of come across it. We sometimes refer to this principle as like, you aren't going to need it, which is like, a programmer should not add functionality until it's certain that it will eventually be used, and it helps remove unnecessary code. And you know, a good example of this is like, we partnered with an API provider to help people invest in managed funds. If anyone's ever used like Raise or Spaceship, you know what I'm talking about. And you know, what we saw developers do sometimes was that they would, when working on this, there'd be some kind of API, right? We looked at APIs last week. This big set of functions. And what they would do is they would, you know, maybe the actual software itself, maybe as far as the users were concerned, there was just a few functions on our end, the API, that might have been like, you know, invest money, and it would take in a customer ID and an amount, and it was a function. And then there'd be another one that was like, you know, sell money, that would take in a customer ID and an amount like this. And maybe that's all the customer does. That's all they do. They can either put money in or sell money. But the API has all these functions with it. And obviously, like, some of these are very complicated. You know, like investing money isn't just like done. You might have to do a lot of complicated things. But the right approach is to start from these functions. Usually the right approach is to start from these functions, which is what the consumer sees, because you know these need to work. Whereas what we sometimes saw developers do is where they went to the API and they went and wrote like tons and tons of helper functions for, you know, like imagine, what was an API that we looked at? Like, you know, that intercom API the other day. That's not the software. That's an ad. The ad worked effectively. Where... There. Yeah, well, what they would do is they would go and write code to like delete a company and retrieve a company and list the companies and attach a contact and detach a contact, because they were like, I'm going to go get all my ducks in line, so that like when I actually do the coding, I've got everything ready. I've gotten all the integrations and connections done. But in the end, there was a bunch of stuff they wrote that didn't get used, you know? Whereas if you actually start from up here, you can be in a much better place, because you're like, well, to invest money, I firstly need to you know, do something, do something, do something, do something. And it's like, it's a way of kind of starting from the top and going down. Now, I can't do this example very well because it's a very like complex, abstract example. But one question I love to answer is this one, which is given two latitudes and longitudes. Lord, come on. Copy, paste. Oh, bugger off. Given two latitudes and longitudes, find out what time I would arrive at my destination if I left now. So that's really interesting because let's say we write a function, right? And the function's called like time between lat longs or something. And we take in like lat 1, long 1, lat 2, long 2. You know. And we want to calculate the time it takes to get between those two. It's really tempting to get lost in thinking about like coordinates and geography and GPSs and stuff. But I actually like to go simpler than that sometimes, which is like, well, what are we actually trying to do here? If someone gives us two latitude long, like that's 2 points on a map. Well, we probably want to just figure out the distance between, right? Distance between equals, you know, or like call it dB. Distance between lat 1, long 1, lat 2, long 2. Okay, that makes sense. And what do they say? Assume I travel at the country's local highway speed. So now I'll be like, well, speed equals get local speed of like say lat 1, lat 2, lat 1, long 1. Like maybe you just get it from where you start. Say, let's just assume the speed limits, you know, there's no speed limits. So you get the local speed, and then you say, well, what do I know? The time is actually just, what is it? You know, speed equals distance over time, time equals distance over speed. I should just call this distance. Yep, and then I just return time. You know, like that. And what's cool about this is that I like to describe this as like I've finished the function, I just haven't filled it in yet. And what you can do is you can kind of like iteratively, recursively kind of cut into the software and be like, well, it's done, but these functions are magic. They don't actually exist, right? They're not npm something. Maybe they are. So now what I do is I go stub them. I go say, well, you know, distance between's a function that takes in, you know, lat 1, long 1, lat 2, long 2. And let's just have it return 1 for now. And then I've got another function called get local speed that just takes in a lat and a long. Doesn't need to be 1. And what that does is that's just going to return me a local speed of 1 as well, right? And now the program kind of works because I've stubbed it, but what I'm doing is that rather than getting too caught up in all of the lower things I need to do, I'm starting from the actual original problem and just slowly like weeding it down. You know, maybe this function I'll write half as well. And you know, in this case, I'll probably just write both of these functions separately, but you get what I hope you get what I'm talking about. It's like you just keep beating down through the layers, and eventually you won't have a function that calls a function that you didn't write anymore, and that function's done. It's kind of like a little tree search in a way, is a way to think about it. So that's a great way to approach software, which is like, you know, that top-down approach. And the question that it stems from again is like, am I speculating about how necessary this is? So maybe someone writes a function, and the function's not used, and you think, well, you sure we need that? Like, how do you know we need that? Because if you know, generally, if you needed it, you should have, like, generally, if you wrote it, it's because you needed it, not because you think you might, you know, that's kind of that question. And then the last question today is, does this follow standard conventions? This is another great question to make your software more maintainable. Has this been solved in a certain way? This one's a bit to unpack, but this comes back psychologically to people like to do things their way, you know? If you write software, you kind of want to leave your mark on it sometimes. Sometimes it sucks too much to write software that, you know, is just npm installs. You feel like you didn't really solve any problems. And also, sometimes you want your own style guide. Sometimes you want your own approach, your own function names and stuff. But if I go right back to the example I said we go back to at the start, right? Here. Do you remember how before I talked about, you know, pulling out this exit function? It does make your code repeat itself less, which is good, but here's the problem with the exit function. Most JavaScript programmers, Node.js programmers, would know what process.exit means in this case. They would know that process.exit1 means that you are going to terminate the process with error code, with code 1, which means error. And what you've done is you've thought that you might be coming across here and making it simpler by not repeating yourself. But this actually made more sense to programmers because they've seen this before. Whereas when you did this, they haven't seen it before. They're like, what the hell is exit? And every time that you force someone to have to kind of learn something new, it's an area where they could get confused. It might make mistakes, something like that. So this is the balance side of this equation, which is that sometimes it's actually better to make software a little less not repeatable, for instance, like this, or more specifically, avoid silly abstractions like this so that you can rely on these standard practices. It's like the people, another good example is like people who do loops and they call it X or something. It's like everyone calls it I. Not when I say everyone, I mean nearly everyone. When you do this, it makes people, like their brain has to think a bit harder and it might mistake it for something else. Whereas when you use I, it's like, cool, if you use a loop within a loop, it tends to be I and J if you're just using it for an index, right? When you rely on these standard conventions, it means you have to comment less too, because other people, other experienced programmers like you will just know what they're talking about. So again, when you write code, ask yourself, is this kind of what everyone else does? You know? And if it is what everyone else does, it's going to make your code more maintainable just by that fact alone. Last comment, if you have any other questions, please post them now, because I'll talk about refactoring for a couple of minutes and then we'll wrap up. And if there aren't any questions by the time I hit the end of this slide, we'll just finish. But refactoring is an interesting idea. And conversations about code design don't finish just because your software is finished. And this is because no one writes perfect software the first time. No matter how much you think about code design, no matter how much you think you're getting it right, you will always have imperfect code and you will always need to, in some way, probably go back and fix things up. Refactoring is a verb that describes the process of restructuring existing code without changing its external behavior. So it's basically changing code internally. Think of it like black box stuff. Like you could refactor a function and the interface doesn't change, the behavior doesn't change, but the actual source code itself does, because maybe you've gone to improve the code design. It's typically done to fix poor code design. That's usually what it's done. Refactoring is generally discouraged if you don't have a strong test suite. Blind refactoring can introduce more bugs. It's a really common way I see students introduce bugs, is like they write software. You'll see this all the time in like student projects and stuff. They'll write software. It doesn't have tests. They'll have a grand idea to go and clean it up. They'll clean it up. They break everything. Suddenly, like, and half the time the cleanup isn't done or not, super helpful. So just be very dubious about refactoring without test suites in any piece of software that really matters. Jeremy says, what if a complex solution is the more efficient one? Clean code versus fast code. I mean, this is why this lecture is written as questions, because again, it's a good question. What if a complex solution is the more efficient one? You got to dig deeper. You just got to talk to people, figure it out, have a conversation. Sometimes that complexity matters. Like what's the difference between a page taking 0.1 of a second to load and 0.2 of a second to load? Probably not much. Probably makes sense to use the cleaner code, the simpler code. What happens if, someone comes along from YouTube and says, hey, we've got this really complex idea. It's a smart way to buffer videos. We can probably save $1 million a day in terms of, data center electricity. It's like, well, okay, that sounds like it might be worth it then, Might be worth some complexity. We talk a little bit about complexity in a couple of weeks to formalize it, but the short answer is it just depends on the situation. There's definitely times you write more complex code just because it needs to happen. No, all gray. That's why it's an interesting topic. Like, there's so few answers on this, and that is why you doing well at it makes you valuable, because it's so hard to point to a textbook or to point to a rule book and say this is the right thing to do in this situation. The answers come from experienced people. And experienced people write a lot of code and a lot of important code. So you get a few experienced people in a room together, they'll usually come up with a good answer to that question, for instance, for a particular use case. Thank you for coming tonight. Please fill in the form if you can or could be bothered. Remember, you can always fill it in even if you're not watching live. These things can be filled in at any time. Please have a great evening. If you have any other questions, please post on the forum. We're happy to help out. And yes, thank you.